Before computers, before regulations, and before modern design rules, engineers built trucks with pure imagination. Some were massive beyond reason. Some were experimental. Some looked so extreme they don't even resemble trucks anymore. These machines hauled impossible loads, crossed terrain with no roads, and pushed engineering far past what anyone thought was safe or sane. Most people today would swear they're fake. They're not. Get ready to witness 10 of the most unbelievable trucks ever built before 1980. Real machines from a time when limits didn't exist. Number 1. Terex 3319 Titan. In 1973, the Terex division of General Motors unveiled a machine so large that it permanently altered the conversation around heavy-haul engineering, the Terex 3319 Titan. This truck was not built as a publicity stunt or experimental mock-up. It was a fully functional ultra-class mining haul truck, engineered to test the absolute limits of size, payload, and drivetrain technology at a time when computing and electronic controls were virtually non-existent. The Titan was constructed to meet the growing demands of large open-pit mines, where productivity increasingly depended on moving more material per cycle rather than simply increasing fleet size. To accomplish this, Terex engineers abandoned traditional mechanical drivetrains in favor of a diesel-electric propulsion system, similar to that used in locomotives. A massive diesel engine powered electric generators, which then supplied electricity to wheel-mounted traction motors. This design eliminated the need for a conventional transmission capable of handling extreme torque loads, a critical challenge at such scale. Physically, the Titan was staggering. Its height rivaled multi-story buildings, and its tires were among the largest ever produced for a land vehicle at the time. Each tire alone weighed more than many complete road trucks. The payload capacity exceeded anything previously achieved, and for decades after its construction, the Titan remained one of the largest trucks ever built. Despite its success as a working machine, the Titan was never mass-produced. Only one unit was constructed, primarily because of logistical challenges, cost, and the difficulty of servicing such a unique vehicle. However, its influence was enormous. The Titan proved that ultra-class haul trucks were feasible and laid the groundwork for future giants in the mining industry. Today, the Terex 3319 Titan stands preserved in Canada as a monument to an era when engineers relied purely on mechanical ingenuity, steel strength, and bold thinking to solve industrial problems that had no precedent. Number 2. Caterpillar 777. The introduction of the Caterpillar 777 in 1974 marked a turning point for Caterpillar and for the global mining industry. It was Caterpillar's first entry into the 100-ton payload class, a category previously dominated by specialized manufacturers. Rather than experimenting cautiously, Caterpillar entered the segment with a machine designed for continuous, punishing work cycles in some of the harshest environments on Earth. Unlike several competitors exploring electric drivetrains, the 777 relied on a fully mechanical powertrain,
paired with one of Caterpillar's most powerful diesel engines of the era.
This decision reflected Caterpillar's philosophy: prioritize reliability, simplicity, and ease of maintenance. Especially in remote mining regions where technical support infrastructure was limited, the 777 was engineered to withstand relentless abuse. Its rigid frame, oversized axles, and massive braking systems were designed to handle repeated downhill descents under full load, one of the most dangerous aspects of open-pit mining. Cooling systems were deliberately oversized, ensuring engine longevity even in extreme heat and high-altitude conditions. What made the Caterpillar 777 truly unbelievable was its operational consistency. Mines quickly discovered that the truck could deliver its rated payload shift after shift with minimal downtime. This reliability translated directly into productivity gains, which is why the 777 became a benchmark against which other haul trucks were measured. The success of the original 777 established Caterpillar as a dominant force in large mining equipment. Its design principles, mechanical durability, conservative engineering margins, and long service life continue to define Caterpillar's haul truck lineup today. The 777 was not just a machine, it was Caterpillar's declaration that it belonged at the very top of heavy haul engineering. Number 3. Euclid R35. The Euclid R35, produced in the 1950s, represents one of the most important milestones in the history of heavy trucks. Long before the term off-highway haul truck became standard, Euclid was designing machines exclusively for mining and quarry operations. The R35 was not adapted from a road-going chassis. It was purpose-built from the ground up to move earth, rock, and ore in volumes previously considered impractical. At a time when most heavy trucks were still based on highway designs, the R35 introduced features that would later become industry norms. A rigid frame designed for uneven terrain, massive axles built to survive constant overloads, and a dump body engineered for abrasive materials. Its mechanical systems were deliberately simple, allowing field repairs using basic tools, a crucial advantage in remote mining locations. The R35's significance lies not just in its performance, but in its influence. It demonstrated that productivity gains in mining could be achieved through specialized hauling equipment rather than simply increasing the number of trucks. This idea reshaped the economics of open-pit mining. Many Euclid trucks remained in service for decades, a testament to their durability. Even today, restored R35s are displayed in museums and private collections as symbols of early heavy-haul innovation. Without the Euclid R35, the modern mining truck industry would likely have developed much more slowly. Number 4. BelAZ 540. The BelAZ 540, introduced in 1961, holds a unique place in industrial history as the first mass-produced mining dump truck of the Soviet Union. Built at the Belarusian automobile plant, it was designed to support massive state-led mining and infrastructure projects across vast and often inhospitable regions. The BelAZ 540 used a diesel-electric drivetrain, a logical choice for Soviet engineers prioritizing torque delivery, mechanical longevity, and simplified transmission systems. This configuration reduced wear on mechanical components and allowed the truck to operate reliably under heavy loads and continuous duty cycles. Unlike Western mining trucks, which often emphasized operator comfort and refined controls, the BelAZ 540 focused almost entirely on functionality and robustness. Its construction favored thick steel sections, conservative stress limits, and straightforward mechanical access. This made it suitable for regions with limited maintenance facilities. The truck's impact was enormous. Thousands of BelAZ 540 units were produced, enabling the rapid expansion of Soviet mining output. It laid the foundation for BelAZ's future development into a world leader in ultra-class mining trucks, including the largest haul trucks operating today. The BelAZ 540 proved that large-scale industrial hauling could be standardized and mass-produced, a revolutionary concept in the early 1960s. Number 5. Kenworth C500. When the Kenworth C500 was introduced in 1972, it filled a gap that most truck manufacturers avoided. While many companies focused on highway efficiency or standardized fleet operations, Kenworth designed the C500 specifically for severe service environments, places where roads were optional, loads were extreme, and mechanical failure was not accepted. The C500 was built on one of the strongest ladder frame chassis ever offered in a conventional style truck. Its frame rails were significantly thicker than those of standard highway tractors, allowing the truck to withstand frame twist, shock loading, and constant vibration. This made it ideal for oil fields, mining support roles, logging operations, and heavy construction work. One of the most defining characteristics of the C500 was its configurability. Buyers could order it in 6x4 or 6x6 drivetrain layouts, with planetary reduction axles and heavy-duty transfer cases. These features allowed the truck to pull enormous loads through mud, sand, and uneven terrain where conventional tractors would simply become immobilized. The C500 could accept a wide range of large displacement diesel engines available in the 1970s, paired with extremely robust manual transmissions. Cooling systems were oversized to prevent overheating during low-speed, high-load operations, exactly the conditions that destroy lesser trucks. What made the Kenworth C500 truly unbelievable was its longevity. Many units built in the 1970s remained in active service for decades, often rebuilt multiple times rather than replaced. Operators valued the C500 because it could be repaired in the field, modified for specialized tasks, and trusted to survive where failure could halt entire operations. The C500 was not a mass-market truck. It was a tool for extreme jobs, and it earned its reputation by consistently surviving work that pushed engineering limits. Even today, the C500 is regarded as one of the toughest conventional trucks ever produced. Number 6. Tatra T813 Kolos. The Tatra T813 Kolos, introduced in 1967, stands apart from nearly every heavy truck ever built. Designed in Czechoslovakia, it was created to move extremely heavy loads across terrain where roads were unreliable or non-existent. Its engineering philosophy differed radically from Western truck design, and that difference made it extraordinary. At the heart of the T813 was Tatra's famous backbone tube chassis. Instead of a conventional ladder frame, the truck used a central tubular spine that housed the drive shafts. Independent swing half-axles were mounted to this backbone, giving the truck exceptional torsional flexibility. This design allowed all wheels to maintain traction over uneven ground, making the T813 exceptionally capable off-road. Power came from a massive air-cooled V12 diesel engine, a deliberate choice to eliminate vulnerabilities associated with liquid cooling systems. This allowed the T813 to operate reliably in extreme cold, desert heat, and battlefield conditions without the risk of coolant failure. The 8x8 Kolos variant was specifically designed for heavy towing and transport roles. It could pull massive military trailers, artillery, and industrial loads across mud, snow, and rough terrain that would stop conventional trucks entirely. Its gearing emphasized torque over speed, making it a true heavy hauler rather than a transport truck. What makes the T813 unbelievable is not just its capability, but its engineering originality. Few manufacturers were willing to depart so radically from conventional design, yet Tatra's approach proved exceptionally effective. Many T813 trucks remained in service well into the late 20th century, particularly in military and industrial roles. The T813 Kolos is widely regarded as one of the most capable heavy off-road trucks ever built, and a reminder that unconventional engineering can produce extraordinary results. Number 7. Scammell Pioneer SV2S. The Scammell Pioneer SV2S, introduced in 1937, was a revolutionary heavy tractor long before modern off-road vehicles existed. Designed in Britain, it was built to perform tasks that ordinary trucks simply could not, particularly military recovery and heavy towing across broken terrain. The Pioneer featured a robust 6x4 drivetrain and a unique suspension system that provided exceptional articulation. Combined with massive torque output, this allowed the truck to tow disabled tanks, artillery pieces, and heavy trailers through mud, sand, and steep gradients. One of the most impressive features of the SV2S was its integrated recovery equipment, including powerful winches capable of pulling vehicles far heavier than the Pioneer itself. During World War II, it became indispensable for recovering damaged or immobilized armored vehicles under combat conditions. The Pioneer's reputation for reliability was legendary. It could operate in environments where breakdowns were expected, and it often succeeded where multiple other vehicles had failed. Its mechanical simplicity made it field serviceable, a critical advantage during wartime operations. Even decades after its introduction, the Scammell Pioneer remained in service. Many units were still operational into the 1960s, a testament to their durability and effectiveness. For its era, the Pioneer was not just advanced, it was transformative. Number 8. Diamond T980. The Diamond T980, introduced in 1940, was one of the most critical logistics vehicles of World War II. As the prime mover of the M19 tank transporter system, it enabled Allied forces to move heavy armored vehicles efficiently across long distances. The 980 was designed to pull extreme loads. Its reinforced frame, heavy-duty drivetrain, and powerful winches allowed it to load, transport, and unload tanks that weighed many times more than standard military vehicles. This capability dramatically reduced wear on tanks and improved operational readiness. Reliability was paramount. The Diamond T980 had to operate under combat conditions, often far from maintenance facilities. Its design emphasized mechanical robustness and ease of repair, ensuring it could remain operational despite harsh treatment. The importance of the 980 cannot be overstated. Without it, armored warfare would have been slower, riskier, and far less efficient. It stands today as one of the most important heavy trucks ever built. Number 9. Mack Super-Liner. When the Mack Super-Liner was introduced in 1977, it represented the pinnacle of classic American heavy truck engineering. Mack Trucks designed the Super-Liner to handle jobs that demanded extreme torque, massive cooling capacity, and structural durability, particularly in heavy haul, construction, and severe vocational applications. This was not a styling exercise, it was a functional response to operators who needed a truck that could survive constant overloads and brutal operating conditions. The Super-Liner featured a long-nose conventional layout with an exceptionally large hood. This design allowed Mack to install its largest engines, including high-torque diesel power plants that required substantial cooling airflow. The extended hood also accommodated heavy-duty radiators, oil coolers, and reinforced structural components, making overheating far less likely under sustained heavy loads. Mack's reputation for toughness was built into every aspect of the Super-Liner. The frame rails were thicker and stronger than those of standard highway tractors, designed to resist twisting and fatigue under high gross combination weights. The truck was often paired with multi-speed manual transmissions and heavy-duty rear axles, allowing operators to move massive loads at controlled speeds. What made the Super-Liner truly unbelievable was its longevity. Many units built before 1980 remained in active service for decades, particularly in construction, logging, and heavy haul roles. Operators trusted the Super-Liner because it could take abuse that would shorten the lifespan of lesser trucks dramatically. The Super-Liner also symbolized the end of an era. It represented a time when heavy trucks were designed almost entirely around mechanical strength rather than efficiency metrics or electronic management systems. For many truck enthusiasts and operators, the Super-Liner remains one of the toughest and most iconic heavy tractors ever built. Number 10. Krupp Titan SWL80. The Krupp Titan SWL80, introduced in the early 1950s, stands as one of the most imposing heavy trucks of post-war Europe. Built by Friedrich Krupp AG, a company better known for industrial steel and armaments, the Titan was designed to meet the enormous demands of Reconstruction-era Germany, where heavy materials had to be moved efficiently despite damaged infrastructure and limited resources. The Titan earned its name honestly. It was one of the most powerful trucks produced in Europe at the time, featuring a massive diesel engine and an exceptionally strong chassis. The truck was engineered to haul heavy industrial loads, construction materials, and equipment essential to rebuilding cities, factories, and transportation networks after World War II. Unlike lighter commercial trucks of the era, the Krupp Titan emphasized sheer pulling power and durability. Its drivetrain components were oversized, and its frame construction reflected Krupp's expertise in high-strength steel. These trucks were not designed for speed or comfort. They were built to move weight reliably, day after day. One of the most remarkable aspects of the Titan SWL80 was its ability to operate under restrictive post-war regulations while still delivering exceptional performance. Engineers had to balance power output, material availability, and regulatory constraints, resulting in a truck that was both innovative and brutally effective. The Krupp Titan became a symbol of industrial recovery. Its presence on construction sites and transport routes represented progress and rebuilding. While production numbers were limited compared to mass-market trucks, the Titan's influence on European heavy truck engineering was significant. Today, surviving examples of the Krupp Titan SWL80 are prized by collectors and historians alike. They serve as reminders of a period when heavy trucks were essential tools of national recovery and when engineering excellence was measured by what a machine could physically endure, not by software or electronics. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.